of the Department of Chemistry at Bozaji University, Istanbul. And she's been a director of the Bozaji University Center of Life Sciences and Technology, and is a center of excellence. Since 2023, Professor Sanyal, who is an inventor or co-inventor of over 50 issued patents and patents application. I think I'll just give you a round of applause right now on that. 50 patents. Her current research interest focuses on targeted therapy technologies. Her academic spin-off, RS Research, is a clinical stage biotechnology startup discovering and developing smart nanomedicine for target chemotherapy, and is translating research to clinic based on the proprietary platforms called Sagita. Professor Rana was awarded with the European Prize for Women Innovators in 2024 for her successful work in the field of biotechnology by the European Innovation Council and the European Institute of Innovation and Technology. She has been named one of the 3 Cartier Women Initiatives 2021 Global Science and Technology Pioneer Fellows. So please help me show her a fantastic Naija welcome by putting your comments in the chat. Please help me welcome Professor Rana Sanyal. You are very welcome, Professor.
Thank you so much, Jadisola, and I'm very excited to be here. It's my first time. I have never been to Nigeria, so it's my very first time as an introduction to Nigeria, I can say.
Right. Well, we are so glad to have you here. So you are tuning in from Istanbul, correct?
Yes, I'm zooming in from Istanbul.
Istanbul. So, okay, for those of you here, please let us know where you are zooming in from. So just type in the chat box where you are tuning in from. Let us know. And let us also, as I said, let's give a wonderful warm welcome to Professor Rana. So we have people from Lagos, Nigeria. Where else? And by the way, while you're here, keep sending that text and message and WhatsApp. Tuning in from Ibadan to Niger State. Oh, wow, we're truly all over Nigeria. Invite people to come on because we're about to get down into some interesting interview here. So I say I'm excited about this because my background is in the pharma industry. So I trained as a pharmacist and I worked at GSK for a number of years. Yeah. For all those years, this was back in the 90s, biotechnology was this emerging part of, life sciences. And my dream company to work for was actually Amgen. I had this fantasy in my head that I was going to go and work at Amgen. I was going to move to Thousand Oaks, and this thing that was biotechnology that I really didn't understand, but it sounded exciting. It sounded really, really exciting. I was really keen to do that. So before we jump into that, I always like to talk to our guests. I just want to ask about what was your background growing up? Did you always like science? What did you do? What kind of things did your parents expose you to growing up?
That's a very good question. I think it helps when you are exposed to some science. In my case, I was an inquisitive child. I don't think I was exposed to a lot of science per se. My mother was an elementary school teacher. She was always, doing experiments in her own class. So I was inquisitive in learning those things. But other than that, I don't think I was specifically exposed to science that much. But this is a different century. My childhood was in 1900s. So I'm visiting you from a different century, right? So at that time, there wasn't this many opportunities to get exposed to things. I think I was playing with the soap and water and trying to make some cologne out of that, and really stealing some of my grandma's cologne and pouring some of it inside, thinking that I was making more of that.
Yeah.
That is the earliest experimentation I can really remember. Um,
So you
but
were naturally inquisitive child. So you were curious and you wanted to find out things and kind of, I guess used your imagination somewhat. Is that correct?
yes, that's very correct.
Mm-hmm.
So most of the things, I think the best things my parents did was they just let me, play with things myself.
Mm-hmm. So you learned through play almost, and you were given the allowance to explore in essence, is what I'm hearing.
Exactly, exactly. So I was allowed to explore myself and sometimes break things, but mostly explore.
Mm-hmm.
Yes.
So what were your earliest memories of learning, in primary school or in school? What was learning and school like for you?
Oh, that's a difficult question.
Okay.
I I really loved the first year of my elementary school. Uh, After that, I don't think I enjoyed it much. My
Mm-hmm.
elementary school years, that was a lot of studying and memorization. That's what comes to my mind when I think about it.
Mm-hmm.
But after that, it was um, by the time I was in sixth grade, I think I enjoyed it quite a bit. In Turkey, it was first 5 years was elementary school when I was studying, and then you had 1 year of English class, and then another 3 years of junior high, and then 3 more years of high school. So that's our system.
Right.
So to be able to go from one level of class to the next one, not from class but from the schools, so from elementary school to junior high, you have to take a nationwide exam. So if you do well, you get into different, types of junior high schools. So I did well in those exams, and I got into a really nice school that did a lot of science.
Mhm.
It taught a lot of science. So I think that was the start. The junior high and high school was the start of all this scientific journey.
Mhm.
Then, when I was in high school, I had a really good chemistry teacher.
Mm.
She was a very scary teacher. So
Oh,
this whole, she was very good but very scary at the same time. Every time, every week, she would, pick you up. You would go up on the board, and she would ask you a question, and you don't answer that, and you get a zero for that, or you get a really low grade. So there was this oral examination habit at those times.
mm.
That was a scary thing because you are all on your own in front of the whole class. You are supposed to answer. And I didn't like the fact that if I cannot answer, to me, it was a lot of humiliation. So I studied and studied and studied chemistry a lot because I was very scared.
Yeah.
So I always tell these to students when they're asking me, how do I find something I love very much and then, work on that? I think it is the opposite. So you work on something, you become very good at it, then you
Mhm.
start liking it. So it's
Mhm.
not that you like and you work on it, but the more you can actually do something, you are good at it, you start enjoying it a lot
Enjoying it.
more than the other things that you might not be as good.
Hmm.
And the way to get to being good is you work for that.
Right.
So my reasoning to start, working for chemistry was because I didn't want to get ashamed while I was on the board,
Mhm.
while I was on the oral exam.
Mhm.
So I studied. So by the time, by the end of my first year in high school, I was already very good in chemistry.
Mhm.
So I really wanted to do chemistry all through high school. I was good at chemistry. It was a choice between math and chemistry, but chemistry always won for me. So I just chose, chemistry
So
after my
it was the
undergraduate.
fear of humiliation and the fear of your chemistry teacher that actually
Yes.
drove you to the love of chemistry. And I love what you said about, sometimes you have to work on something to like it. Because I think, nowadays, we're often told that, find your passion. And
Mhm.
if you find that passion, then you'll be inspired. So sometimes your passion or what you like is not always immediate. It's something that I'm hearing that sometimes you have to work at it for you to now eventually like it. And I see resilience there in terms of not giving up as well.
Exactly.
Mhm.
I think resilience is a key word. So I always thought when I was, we will come to my story, what all I have done,
Yes.
from science all the way to now medicine.
Yes.
But I think the whole success behind the story,
Mhm.
I always thought it's the resilience, because I'm not like, okay, I'm not dumb. I have some kind of intelligence, but I'm not the most intelligent person I know. I'm
Yes.
not the best chemist that I know. So
Mhm.
how did I become successful in taking something from science, inventing something, taking it to human, making a difference? I always thought it's resilience. Recently, I have come to another conclusion around this. When I think of resilience, I always think that you have something, you are resilient and you don't fall down.
Mhm.
I don't think that's it. I think the word is not resilience. Um, there is a children's toy in our country. I'm sure it is there in every place. Like you knock it down and it kind of comes back up
Comes
because
back up. Yeah.
yeah, it immediately comes back up because of its center of gravity is at the very bottom. So if you knock it down, it will come back up again. I think it is that I'll find out the English term for it. I forgot. It is that you get knocked down.
And
How
then you get.
fast do you get up?
Mhm.
From it's not just resilience that you are, when something is pushing you, or you
Right.
get
You keep pushing at
you,
it. Sometimes you
you
actually
keep
do
pushing at it,
fall, and
but
then
you fall. It's okay. It just
it's,
goes above you, and then you come back right up. I
it's
think that is what we need.
fantastic. I love that. So it's not the fact that you keep pushing at something. Sometimes you do fall, but the difference is getting back up again
Right.
and moving on. So I love that. That even though is a we maybe have to shift our definition of persistence or perseverance. You're sticking at it, but sometimes in resilience is when you come back up. After you've been knocked down.
Yeah.
So welcome everybody. I know we have some people just joining us. If you're just joining us, we're here with Professor Rana. We're very excited to talk to her. And so we'll dive into some of the questions. So you had said that, and I love what you said, that it wasn't that you were the best chemistry students. You were not, but you worked hard. That's something that and I'm hearing. So how did you now go? Because I know your background is in chemical engineering. Can you take us through that journey of how you went from chemical engineering to biotechnology and drug development? What inspired you what got you on that pathway, and what has kept you all along now where you are in medicine?
Okay. I'll start from the beginning of the story. So, from high school to undergraduate degree in chemical engineering, I really loved chemistry in high school. My We again have a university entrance exam at the end of high school, going into college. So in that exam, I had really high grades, high points. So chemical engineering was higher, so I opted for that. I didn't know that it was more engineering and less chemistry in there.
Chemistry.
Yeah. So I did engineering, but I always enjoyed chemistry, so I took quite a bit of extra chemistry classes. And then while going for PhD, I only applied for chemistry so that I can, get into the field that I really wanted to learn. I loved organic chemistry from the very beginning. So organic chemistry is how you take one atom and then another one, and then you make a bond between them.
Mhm.
It's a matter of that you make something new completely that did not exist before. That's very exciting for me. I get excited about just thinking about it right now, that you can take something and you can make something else out of that has no resemblance of the first thing, that didn't exist before you made them. So
Mhm.
that is very exciting. So I loved organic chemistry. I did a PhD in organic chemistry, learned how to make these bonds. Then comes the Amgen experience. That is first started in medicinal chemistry, and just like you said, it was somewhat in biotechnology and a lot of proteins, peptides, conjugation technology. So that's a lot of technical words here. But so I learned, the best thing I think I learned from Amgen was how to take a molecule and how to make a medicine out of that.
Okay.
So as organic chemists, we make chemical molecules all the time. But it doesn't mean that they become medicines.
Medicines.
So I had no pharmaceutical background. I wasn't trained like yourself. So taking this chemistry knowledge and making it into a medicinal chemistry knowledge was something I learned in Amgen.
So you learned that on the job, so to speak.
Yes, yes. And I was very lucky because I had this experience of taking a molecule and really moving it forward to clinic. I saw all the steps going forward, and I saw how it felt. I'll just make a brief short parenthesis in here about an experience in Amgen. Maybe that will inspire some of the people here. So once you take from the preclinic to clinic, this is preclinic is all the synthesis and then animal studies and everything, and then clinic is in the hospital. When you take something from there and move it to human side, we don't have any connection to the scientists. But every 6 months, we had this meeting for the entire company, and they will tell us what has happened to the molecules that are moving forward, what is ongoing in the company, whatnot. So in one of those meetings, they showed us a video of a patient who received this medicine that we were making. He was, in really severe condition, in a hospital bed, in coma. I was always working on cancer, so this was a cancer patient. So he received our medication, and at that time there wasn't much hope for our molecule either. We didn't know what it was capable of. And then after some time, they had another video of the same patient, and they were showing it to us back to back in this meeting. The patient is sitting in his bed, eating food. First he was in coma, now eating food after our medicine. There is this amazing feeling that I had that you made a difference in someone's life. It changed something. So after that, everything I have done was to relive that moment one more time. That inspiration, I kept that inspiration in the last, I don't know, over 20 years now, that making a difference in someone else's life like that, like an amazing difference like that, was something very inspiring for me. With
So
that,
it was really you gave that person life again because through the medicine they were able to be restored, because the last time you saw them they were in the bed in coma, and seeing the impact of that molecule that was translated into a medicine truly give that person a chance of at life again.
And that that person received some chance, and I received another chance for myself by being part of that journey. I learned a lot of things, and I had a lot of inspiration out of that for the rest of my life, basically. And
I like the fact that you keep saying, that's a source of inspiration that you go back to and to relive that moment.
Yes. Because it's I still see that movie in front of me while I'm talking about it. It is still very alive in me. So after that, that's of course quite some years in Amgen as well. I really wanted to go back to my home country, and whatever I have learned, I wanted to do those things in Turkey. So in 2004, now almost 20 years ago now, I returned back to Turkey, started an academic lab in Boğaziçi University in Department of Chemistry, an organic chemistry lab that will make medicines. And my focus in there was taking these medicines that I saw that they were causing a lot of side effects to patients. So I've always worked in cancer most of my career, still continuing on cancer story. All these chemotherapy agents, when we are trying to cure the cancer, if you take these tumor cells outside in a petri dish, you throw these molecules, we know how to kill the tumor cells, no problem. It's not just me, everybody knows.
Yeah.
We can kill those tumor cells. The problem with curing cancer is we cannot find those cells in your body. So we give so much of the medication, trying to just shoot everywhere, just so that one of our bullets goes and hits the cancer as well. So with that, we are causing so much unwanted effects to the rest of the body that we are not able to increase the dose of the medication. That is why most of the time we are not able to really affect the cancer, affect the tumor. But otherwise, if we could like isolate the tumor, we can, we have the tools, we can, destroy the tumor cells, no problem. So my whole research is based on this: can we target these cells, find something unique about them, and there are many things that are unique about the cancer cells, use those informations, and we target the tumor, and we do not affect the rest of the body.
Yes, the healthy cells.
The healthy cells, exactly. And the healthy cells, what are those healthy cells we are trying to get rid of, not affect? First of all, it's the bone marrow. That is where you produce your red blood cells. If you destroy them during chemotherapy, that is why the patients are tired. That's because they are not able to carry oxygen around. The red blood cells are gone. Same thing about white blood cells, because again, the bone marrow, the patients are not able to fight with other diseases. Their immune system gets down. Other than bone marrow, it is the inside lining of your mouth, the stomach, the whole gastrointestinal system is affected by chemotherapy, because those are again fast reproducing cells. That is what we try to stop all the time. The hair follicles are fast reproducing, so we stop those as well. Eggs in women. So many of these, excuse me, many of these cells we really do not want to harm, but we harm anyway because they are also fast reproducing, just like the tumor cells. So if we can target these cells, we can make a difference. So I came back to Turkey and Istanbul and set up a research lab in this Boğaziçi University institution, trying to make these targeted drug delivery systems. That's how my research started.
So they're almost precision medicine, as they're called, right? In terms of trying to target the tumor cells only and not the healthy cells. I think you've already answered part of my next question, which is that many of us have heard about cancer and the importance of finding new treatments. So it's just, are you able to explain to our audience in simple terms what biotechnology and nanotechnology are, and how they're used in treatment of various diseases? I guess in your case, oncology.
I'll start with nanotechnology, what it is. Nano is something small. So you know what is 1 meter? 1 centimeter is 100th of a 1 meter, right? So if you do 1 millimeter, it is 10 to the power minus 3 meters. If you do 1 micron, that is 10 to the power minus 6. So that is 1 over 1 million times.
Yeah.
Okay. 1 meter is 1 micron. And 1 over 1 billion is 1 nanometer. So if you think about atoms, an atom between 2 carbons, let's say, the bond here, we measure that with angstroms. That is 10 to the power minus 10. Nano is 10 to the power minus 9. So we are talking something a little larger than small molecules, like, for example, aspirin I'm sure everybody is familiar with that. We would measure it in angstroms, the size of that. It will be less than 1 nanometer size.
Wow.
So the nano that we are talking about is lots of aspirins coming together, for example, or other things like we call them polymers coming together, or some particles coming together and making into a nanomaterial. So we are talking about something very, very small. To give an idea to our audience, your red blood cells would be around 2 to 5 micron size. So we are talking about medicines that are almost 1,000 times smaller than your red blood cells, so that they can go everywhere in your body. They can penetrate into the tumor, get stuck in the tumor, for example. So that is nanotechnology. So not so small like the aspirin, little larger than that. And that has some advantages, but I don't want to go into too much technical details here. But nano size is somewhat still smaller than all of your cells in your blood. Now, coming to biotechnology, these nano stuff, think of them as spheres. You want to have something on them that is going to go and recognize something like this coming and recognizing the tumor. This piece, it will have to recognize the tumor surface where it is going to go and say, oh, this is my tumor cell. And then if it touches a normal cell, it will say, oh, there is nothing here, so I don't stay here. So this piece is what the biotechnology is in my case. That is going to go recognize this surface. These are called receptors on the surface of the tumor. So it is going to go catch that receptor and say, oh, found the tumor cell. And then the whole thing gets inside the tumor cell because of that.
Wow. So it's like a vehicle is assisting the medicine in getting and targeting the tumors in essence. So it sounds as if there's a lot of biology in there. There's a lot of chemistry in there. There's a lot of engineering of sorts in there. So I just wanted to ask you, for some of our parents in the audience who are listening and trying to also get educated, for children who maybe are interested in medicine, and medicine has changed. The scope of medicine is so wide now. For children who are maybe interested in getting into science or medicine, what advice would you give them at this stage? So let's say they're in middle school or high school. What sorts of opportunities or experiences can their parents expose them to just at this age, and trying to, maybe the child has heard this and inspired, and you know what, I might want to go into what Prof is talking about. What would you say to the parents now in terms of the sorts of things they need to start thinking about? I mean, I know it's early, but what kind of experiences can they expose their children to?
That's a tough question. Nowadays, I think you can find everything on internet. So there is a lot of things on YouTube that they can watch. The best is to, first watch it yourself and figure out there are many channels. I have two sons. One is 10 years old now. So I know he finds now on his own many things. He's more he can reach to other things that I don't even understand most of the time. My elder son is now 20 years old. So he's also studying in college and studying engineering. When he was younger, I was more instrumental in finding things. But nowadays, I think the 10 years in between, the world has changed so much in between the two that the younger one is a different generation. So it's just 10 years between them. The younger one is a new generation. They call them Alpha, but I think he is after Alpha. We haven't named them yet.
I've lost track.
Year-wise, he's supposed to be Alpha, but I think when they are a little older, they are going to change the name. These are not like Alpha either. I know a lot of Alphas, This is a different generation than even alphas. Generations are changing so fast now. So anyway, I think letting them, be on their own, um, guiding them through exploration, but then letting them explore themselves, I think is the key.
So,
Because even in college, we are trying to teach things. I'm still a professor at a university, right? I'm teaching many young adults how to do things. But
mhm,
in terms of doing teaching knowledge versus teaching, how to find things and how to
mhm,
analytically think about them, I
mhm,
think is where we are heading towards. So
mhm,
knowledge is really, cheap. It is they can reach if they get like a some kind of smartphone in their hands, which children who are at the age of their when they are teens right now, they have phones. If they don't have it by now, they will have it when they're in college. They
mhm,
can reach any kind of information they want. Information is cheap, but
mhm,
analytically thinking about that information, and then deciding whether that information they received is correct or not, being able
mhm,
to question that, being able to ask the right questions.
mhm,
I think the best thing parents can do to their kids is talk to them,
mhm,
and mostly not talk to them but listen to them.
mhm, mhm.
So
I think
give them the opportunity to talk to you.
uh, I like what you said about, the transition from teaching knowledge and information is cheap, to actually teaching them, how to think, which is what STEM education is all about. STEM education is not teaching, what to think, it's how to. And as you said, how to handle information, critically assess it. People always think STEM education is all about science. It isn't all about science. It's categorized into, learning skills, which is
Mhm.
critical thinking, problem solving, communication, literacy skills, which you've talked about, research skills, being able to assess information, being able to analyze it and apply it, and also life skills. So those are the skills we should be teaching. You can get knowledge, especially in this day and age. As you said, information and knowledge can be obtained from anywhere, but what you do with it is actually the key. So it's really guiding our children. You talked about letting the children explore themselves, but also guided exploration, which can come from listening as well as talking to them. And I'm glad that you mentioned that. As we, one of the main objectives of what we're trying to do with our learning festivals is to really also educate our parents, that it's not all about acquiring and cramming all this knowledge, but honestly, it's what you do with it, and really encouraging them to learn how to learn, and and how to think and apply knowledge. So thank you very much for reinforcing that, because really that's the aim of what we're trying to do with our platforms. So I'll just take a pause for a minute. I'd love to take questions in the comments section. Let's make the most of this opportunity. Professor Rana is very busy, and we're just so excited to have her here. What questions do you have as parents, as teachers, as school owners, or as someone who's just here, just to learn yourself? What questions would you have for Professor Rana? So please type that in there so that we can make the most of this opportunity and really learn from her. Um, I think most Nigerian, when you ask them, at least of my generation, what do you want to be when you grow up? Doctor, lawyer, engineers. Those were the sort of careers that were available in our generation there, that were deemed, the good one. But even in medicine now, because you've transitioned from really starting off in chemistry to medicine. So what would you actually call yourself now? A medicinal chemist, or a medicinal researcher chemist? What would you call yourself? Let me let you speak.
Um,
While our parents drop
I
questions
still call myself a chemist,
at chemists.
but mostly I'm now an orchestra, chef.
Oh, I like that.
um, not in music, of course, but
Yes.
there's so many disciplines. If you think about from the chemistry, biology, then
Mhm.
there are a lot of pharmacy fields that I'm working with. I'm working with a lot of medical doctors. Um, from that, the entire thing of communication comes to mind,
Mhm.
making all of these things and then communicating to very many different stages. We have to communicate to the public, we have to communicate to our funders, funding structures, for
Mhm.
example, to the government,
Mhm.
to many stages, to other scientists, we have to communicate. So that is also in there. There's a lot of operations going on. There's a lot of course, financial things going on, right?
Mhm.
Clinical stuff that is going on. I don't
Mhm.
want to miss anything, but we were talking about patents. There is a lot of intellectual property stuff
Mhm.
that is going on. So there
Mhm.
is law
Mhm.
plus medicine science in there as well, and there's a lot of quality control, quality assurance. There are so many different fields of people that I'm working with. I think that is the orchestra chef is pretty much what I do during most of my day. Uh,
Mhm.
so while the questions are coming up, I'll just mention about this. How did it become a medicine? So I started my journey as an academician in a research lab. Started my research lab, kept writing grants, trying to get funding, set up a lab where I had PhD students, master students, undergraduates doing research. Some of the data looked really good, looked really promising. And I had seen very good data in Amgen. I think that is what was the best part of being in Amgen. I knew when I saw a good data,
Mhm.
and then the whole thing started with my brother saying that, okay, if you want to push this now to human, that you really want to make a difference with these materials into medicine, you have to have a startup. I am usually not a person who takes chances. I'm not a taker.
Mhm.
Um, but I think I had the courage somehow, mainly because of him, because of my brother, who said, okay, you can do this. Started a company, joined with him. So he's my co-founder.
Mhm.
That is, I think, my one of my biggest luck, that he had already started many companies before. He was a
Mhm.
successful general manager of another company. We started the company together, got some funding from investors, and then eventually moved our first molecule to clinic, to human. Now, the importance of this is in Turkey, we never had any new medicines coming from research going into clinic.
Mm.
Turkey, we don't have a drug of our own.
Wow.
None. Okay. So this is the first molecule that we did all the research, we own all the intellectual property, and now it is being tried in clinical trials in human. So that
Fantastic.
is that is the important impact. That is the important part of this story. If I was coming from one of the countries who have made medicine, millions of times before, if I was coming from US, or if I was coming and telling you the same story from Switzerland, for example, it would have been impressive still, making a medicine and it's now in clinic. It's always impressive. But doing the very first one, uh, is a lot harder
Mhm. I think that's
from
fantastic.
different aspects.
Because for the non-scientists here and non-people in drug development, to do that is a big feat. In those days, they used to say it takes almost 15 years to get a drug from, the lab to the market. It takes almost 15 years. So, I mean, each stage when you move from preclinical to clinical, it's quite a milestone. So congratulations. I mean, That is just fantastic and well done. Oh my gosh, we have so many questions here. But let me just quickly go
Yeah,
back to
let's
what
go
you
to the
were saying.
questions.
Yeah, what I wanted to say when you called yourself orchestra chef was that you mentioned a multidisciplinary group. And for me, I just wanted to draw out some of the potential careers within the pharma. So people, you don't have to be just a doctor. You know, you said chemist, biology, pharmacist, communication, legal, operations, finance, quality assurance, data scientist, data analyst, quality control, just to name a few. You have business development, you have regulatory affairs, which is where I worked. You have to, all this work is for nothing if regulatory affairs doesn't register it. So I just wanted to highlight to those listening the, plethora of career opportunities that are available, and you don't have to be a doctor. I guess that's the point I want to draw out there. So let me just jump into the questions quickly. So I have a question here, which says, can a microbiologist transition into biotech or nanomedicine? If yes, can one do that easily? I think is what she's trying to say. So microbiology in biotech, yes or no?
Definitely yes. So we do have a microbiologist working in our company as well. So whenever you are producing something, you have to produce, if you are producing a medicine, you have to produce it under very, very clean conditions. These are known as GMP conditions, that is good manufacturing process product. So you have to do this manufacturing has to be very, very clean, because you can actually harm a person with the medicine that you have made if you didn't make it properly. So at the end of your production, what you do is you need to check whether there are any remnants of bacteria, for example, in there. You have to be checking this throughout your process, and you have to be checking at the end of your process as well. So you can be a microbiologist directly without changing into anything else, and be working in this production part of the medicine as well. To be able to take these nanomedicines that are quite complicated, and they are globally new. It's not new for Turkey, but it is new for any country. So these are going to be global medications for oncology patients.
So it needs
to be able to produce something like this in Turkey, we had to establish a production facility as well. Okay. So when we are talking about, hey, you cannot do this because we don't have the money, because we don't have the manpower, because we don't have the facilities, we had to practically set up every step along the way.
Wow.
Animal facilities, it didn't exist. We set those up in universities. Now there are many more in Turkey. The production facilities. We were the first clinical batch production facility in Turkey. Now more are coming up. So when people see that it is doable, there are more people who get this yes, we can do it kind of attitude.
Fantastic. So you were innovators in so many ways, actually, in your industry, in your country.
Yeah, impact comes from different areas.
Different areas.
Let me go back to the microbiologist. So as a microbiologist, a person can be working in the production facilities. Every production facility usually has a microbiologist. But if you want to change and learn more of nanotechnology, you want to learn more biotechnological production, that is all these biological proteins or antibodies, for example, are produced via biotechnological methods. If you want to go and learn into those, why not? Look at me. I don't have a career path that is going like whoosh up like this. Chemical engineering, started from scratch in chemistry, went up again, from chemistry went into biotechnology, went up again. So there is industry, academia, another industry, again academia. So I'm all over the place. If I can do this, why not? You can do it too.
Wow, right? Fantastic. Thank you so much. Let me ask another question. It says, can you please speak a bit more on patents and how your work was integrated with patents and patent applications?
So we do write patents in the pharmaceutical industry. In some of the industries, it is not very critical to have patents. In pharmaceutical industry, it is very critical to protect your information through patents, because taking a molecule and making it into medicine, we just talked about it. Jadesola said it in a minute ago, that it takes many, many years. So it's not like you made a new app and then you are able to sell and make money off of it. You need to be able to protect it for some time. And when you are doing a patent application, it is protected for 20 years. Within those 20 years, you are eventually going to come into the market, be able to sell and make money off of that, so that you can fund your research back again. So we do write patents, apply globally. There is something called PCT that you can apply for world patents, and then you enter to the countries that you are interested in selling your product. That takes a lot of effort, a lot of money. To be able to do all of these things, we have gotten venture capital investments to our company. Let me explain what that means also. Maybe people might be interested in those as a career path. If people from undergraduate also listen to us, or graduate students listen to us later on, along with their families. So that is, we set up the company, we own 100% of it to start with. And then when venture capital comes and says, okay, we are going to invest in you, we give some percentage of the company to them. So they have to evaluate and make a valuation of our company at that stage. And patents are part of the valuation process. So that increases your value quite a bit if you have some global patents or global patent applications, for example. Then you get the money, you work for a while, the money finishes, and you go to more venture capitals.
Right. And you give them more of your
You give them more of your percentage. So you don't want to give all of your percentage at the beginning. So you need to be able to save some.
So I have another question here. And this is really talking to our parts of the world, global South, that all this is fantastic. We have students in the global South who are studying biotechnology or in the fields of biotechnology, but don't have this level of research and technology is not available in our countries. I'll use Nigeria as an example, and this is from a question here that, look, I've studied this and I have a degree in biotechnology. I'm in Nigeria, but how can I build a career or gain experience in the field of molecular medicine or biotechnology in a country that doesn't have an existing or still has a nascent industry? What advice would you give? And this person doesn't have the opportunity to leave. What advice would you give that person?
That is either too easy to answer for me or too difficult to answer for me. So in my case also, in the field that I wanted to do my PhD, it didn't really exist in Turkey at the time. So I applied for scholarships. I did not go with my own funding. I didn't have resources to take me abroad. Even buying the plane ticket was already too much trouble for me at the time. So I got scholarship to do my PhD. Then I worked for a while. Then I came back. Again, the lab that I started in didn't even have the proper benches. So I applied for funding. I applied for international funding. I applied for local funding. I applied for national funding. I kept applying. I got rejection many, many times. My rule is I get a rejection, I get to complain and say bad words and whatever for the first hour. I have a full hour for that. 60 minutes is up. It finishes. within the same week, I have to send 2 more applications. That's my
So
rule.
one rejection
2
equals 1
applications.
hour of venting and then 2 more applications.
Yes.
Okay.
So eventually you get some, you know, it's a matter of ratios and odds. You get some, you lose some, it doesn't matter. So now also, you know, sometimes I don't need the full hour, sometimes I do. But 60 minutes is good enough. So you apply for more, you apply for more. In my field of research, when I was in the university that I came back, it's a very good university. It's the top university in Turkey, but the area of that research did not exist. What I was making dendrimers at the time. The word dendrimer and Türkiye did not exist in literature. Like you type the two together, you get 0 of literature also from there. So we are not talking about, you know, I didn't go back to a country where it was like they were waiting for me with flowers in their hands and everything was all set up and I just walked in and made a new medicine. Instead, I heard this, that you cannot do this so many times that you will not even believe it. That it is too expensive, we don't have the manpower, we don't have the resources, we don't have the facilities, we don't have this, we don't have that. So be the pioneer. It's a blessing in disguise.
I like that.
It makes a more fulfilling story at the end. The fact that you didn't have in the first place, that's an opportunity. That you can see that as a negative thing.
Fantastic. Thank you so much. That's so
inspiring. Opportunity.
I like that. So vent, but let's just not stay there. We need to move out of that and do something engaging. So I have another question here, that for a child who is in high school looking to pursue a career in biotech or nanotech, what area would you advise them to focus on? Chemistry, biology, or engineering, or all of the above?
Anything is fine. Depends on really the child's, what their interest is. Okay. One of them is not going to be enough for them anyway. So they will have to learn complementary fields when they are going along. So if they are going to do really something groundbreaking, if they are going to really make a difference, it is not going to be that they're only going to be doing chemistry or doing biology. So whatever their interest, doesn't matter. Just be prepared for the fact that any child right now who is in their teens, for example, will be changing their career at least 4 times. Okay? Not jobs, their career 4 times. Okay. Till the time that they are going to retire. So it doesn't matter what they study in their undergraduate. We are trying to teach them how to think, how to solve problems, and how not to be afraid to change their field again. So with all the artificial intelligence, the AI is coming up, who knows what we are going to be talking about in 10 years. Forget about 40. By the time they are retiring, right there, we are talking about 40 years later. I cannot dream about that right now. But how can I teach them how to do things 40 years later? I can only teach them how to think and how to solve their own problems.
Exactly.
I can only, teach them that there is something called a hook that you can go fishing for yourself. And they will have to extend the idea that it's not even fishing that they are going to require 40 years later or 30 years later or even 20 years later. We cannot imagine right now.
I love that.
So I love that. They choose. Who cares? They let them do science, let them do engineering, whichever fits them better. They can do either one, and you can keep going back and forth between them.
So we're thinking that our focus is really those skills, those future-ready skills, to teach them how to think and how to problem solve, because they'll be changing not jobs, but careers up to 4 times. And I think that's part of, in fact, I've even forgotten to highlight this, that really this is part of what we're trying to emphasize in our STEM festival. I mean, I don't know how many people, do we have our poll up? I know I was supposed to have brought that up a lot earlier, in terms of how many people are even aware of our STEM festival. that's coming up not too long, actually. We have in Abuja, July 13th, and we have in Lagos, July 20th. How many people here are aware of our upcoming festival one? And if you are, okay, so the poll has gone. Have you heard about the STEM Africa Fest? So please answer that quickly. We have another poll coming up. Have you heard of our STEM Africa Festival? So, and why is the poll closing? We haven't even had enough time. We have a second one that's asking, have you registered yet? Are you aware that registration has started? So can we have the other poll while we are also talking? I know we're almost out of time. I'm sure we can spare another 5 minutes. So let's see. Of the people who are able to answer, one person hadn't heard of it. Are you coming to the festival? If we can put that up. Have you registered yet? So we have let's get people an opportunity to please fill this in. Have you registered and bought your tickets for the STEM Festival? Please let us know. And if you haven't, so the options as yes, I have bought my ticket. Yes, I have bought my ticket and even invited someone else. No, I have not at all. So let's see. Have you registered? Have you bought the ticket? Have you invited someone? Or no, you haven't? Wow, a lot of people have not. What are you waiting for? We only have set number of tickets, so and if it's gone, it's gone. So a few more seconds, 38 seconds. Have you registered? Have you bought? Have you invited somebody else? A lot of people haven't. Well, I don't know what to tell you when the when the tickets run out. For those of you who need more information, we'll put up the website shortly. And we also have a WhatsApp group that you can join where you'll get more information. And it's called All Things STEM. Fantastic information that we share there. We have a community of almost 1,000 people on that WhatsApp platform. So please, join us. I'll just go back to my questions before we round up. We're actually over. Let's have a look. Last thing you said was that be a pioneer. People always talk about, let the doors be open to you. And I know I've read somewhere that it says, well, if the door isn't open to you, build one, which is what I think you have done. One of the questions I have for you was that, let's see. If you had any advice for your younger self, your younger 15-year-old self, living in this generation, what would that be?
That's a good question. So I'm just very recently head of our science agency in Turkey, the National Science Agency. On the stage, he called me very stubborn, while he was describing me. He meant that as a very nice way. So I think I have been very stubborn in, doing things, in trying to pursue things. But what I really believe in is things that we need to give up things. Okay, what do I mean by that? So when I'm talking about a project, for example, and I'm trying to move one of my molecules forward, you need to ask the right questions first, the most important questions. Is this really going to work? Not just I'm collecting some data on it, but a really critical question, whether that molecule is going to be finally successful or not. You ask that critical question, and if the answer is no, you give up on that molecule, because that is your opportunity cost, that you are not really moving forward with something else. Being stuck to an idea that I'm going to do this very stubbornly, but not really looking at anything else, not asking the critical questions, I think mostly derails many young people that, okay, I'm going to become this. When you give up something, it doesn't mean that you were unsuccessful. It means that you were smarter. You are looking at a different opportunity, that you close the door, but you have a window that you are looking through.
Oh,
So
sorry, carry on.
so it is not that, you persist on something. I think I did persist on many things in my life, but I would have told to my younger self that when you chose not to persist on things, it, I was very harsh on myself. That, oh my God, this is unsuccessful. I was very mean to myself many times. So I would say to my younger self that be kind to yourself. I think that is most important thing. Especially this is something to tell to women. Somehow we are harsher to ourselves. So be kind to yourselves. That I would say this to my 15-year-old self, that be kind to yourself throughout all of this. And when you decide to give up on something, that might be the better choice than really trying to stick to it, because there is the opportunity that you are going to do something else that is worthwhile and you are going to be more successful with that. So these are, I think, the two things that come to my mind.
I love it. So be kind to yourself, especially if you're a woman. Giving up may actually be a better choice. And I just loved what you said, that sometimes you may be closing the door, but maybe you have a window for you to be looking through, or a window is available for you. And I'll just round up with this last question. Being a woman in science, was that a struggle, a challenge, an opportunity, or both?
I think it's all of them.
Yes.
To me, in many places, I honestly do not notice being a woman is being different. But that's just somehow I don't look around for things. So I'll just tell a very short story. So I just recently told this story again. So um, when you say something in a negative sentence, okay, that do not do this, your brain do not understand that negative sentence. So for example, do not think of a giraffe. Right now, anybody, do not think of a giraffe. So, you're all thinking of a giraffe right
Yeah.
now, right? Even though I said do not, you can hear it, but you still think about it. So when you are thinking about obstacles, you're always thinking about the obstacle, that, how do I jump around it? How do I go around it? How do I go around the obstacle? Don't focus on the obstacles. Look at the path. There is a path around them. Sometimes you are going to jump over them. Sometimes you are going to go sideways, find your way. Focus on the path that is open in front of you. Do not focus on the obstacles. So if being a woman was an obstacle, I don't know, I didn't see it. If, being too young was an obstacle while I was trying to do all of these things, I don't know, I didn't notice that.
Mhm.
If being in Turkey was an obstacle, sometimes I did notice that. But most of the time, I try not to, look at the obstacle. Of
Mhm.
course, plan. Of course, have your strategies. Of course, have your B plan, C plan, everything. Strategic thinking is, the way to move forward. But do not focus on what is in front of you as an obstacle, what is in front of you as a hurdle. Just, you are going to keep, you will jump on them.
Mhm.
Science itself is already difficult. Making a new medicine, it is already very difficult. So I have um, this enemy that I'm fighting all through my life, that is cancer. But it's
Mhm.
an honest enemy. I mean, it doesn't know that I exist, right? It is just trying to, be multiplying and be surviving cells by themselves. They don't
Mhm.
care about, what it is. But it's an honest enemy. So I like honest enemies, I guess.
I love that. So, and I was even going to mention that when I was reading about you, that you're an athlete and hurdles are your favorites because you see obstacles as a reason to inspire people to jump higher instead of stumbling and falling. So as you said, the obstacle, you don't see it. It may be there. It's all about perspective.
Yes.
And as you said, it's finding and forging that path because we all have, there's enough enemies in even just trying to live and exist and just not focusing or giving the attention to the obstacle. It doesn't mean we are in denial. It's just a perspective and a mindset that you have chosen. And I just love that. Professor Sanyo, thank you so, so much. This has been so inspiring, even for me myself, that there's enough to contend with in living your day-to-day life. Let's not add to it. And let's just focus. That door closing may be the best thing that's ever happened to us. So I just wanted to say thank you on behalf of all of us from STEM Fest Africa. We want to say thank you so much for gracing us with your presence and the nuggets. I myself, I have this, I think I'm going to actually make some cards and of some of the quotes and nuggets you've shared with us here. We're truly grateful. Let's show her some thanks, please, in the comments. Thank you for the time. And really, I think you emulate what we are trying to do with the STEM Festival for our children to learn, for our children to really know how to think and problem solve and ask the right questions, for them to have and be equipped with the skills they need for the future and these numerous careers that they're going to have. And it's really having the right mindset also.
Jadisola, thank you so much for having me, to Titi also for inviting me over here. I really appreciate this, for the opportunity to be able to talk to so many people. I know you are going to put it on YouTube also.
Yes. Yes.
So this might go into even places that we didn't dream of, you didn't dream of, I didn't dream of. I think it is a matter of all of this ecosystem, the whole world really rising up. That is when we will be able to make these medicines, make these game-changing things for climate, for food, for medicine, for all of those things. When everybody is working towards, towards these goals, and we have each other's back, I think that is the biggest lesson that I have learned throughout all of this journey. There has been many people behind my back trying to push me forward, many people in front of me, giving their hand and trying to push me forward as well. So out of all of this, especially for the women scientists, scientists wannabes, to the girls who want to be in STEM, to the boys who want to be in STEM, and to everyone, that it is either all of us that we are going to raise in level and solve these really global problems, or we are not, we are all going to perish. That's it. That's
right.
That's my last lesson. Right. It's either all of us or it's nothing.
Nothing.
Not just one scientist, one country, one this, one that.
We all have
all of us. We all have to do it together.
Fantastic. Thank you so much. And thank you so much to our viewers as well. Like I said, this is the second in the series of pre-events that we have for the upcoming STEM Africa Fest. We have another speaker next week. I believe it's the founder of Mad Science. So that should also be very exciting. So again, look out for the registration information. Make sure you share it with your school, with your parents, with your friends, for these inspiring speakers that we've been able to bring together ahead of the STEM Africa Fest. Please, before everybody jets up, our feedback form, please fill that in so we get feedback so that we can hear your thoughts, or maybe even hear speakers that you would like to hear from. Please take a few minutes to fill out the feedback form. It would mean a lot to us. And again, as we've said, if you haven't registered for the festival happening in Abuja and Lagos, so we are going to Abuja this year, please, I'm telling you now, once the tickets are gone, they are gone. And we're just really looking forward to having everyone together again. So, yes, thank you
Go
again.
STEMFest Africa. Yes.
Thank you. So thank you again, Professor. Enjoy the rest of your weekend. We really appreciate. We'll share the links with you as well.
Yes.
For you to share. So thank you, everybody. Enjoy the rest of your weekend, and we'll see you next week. Thank you and goodbye.
Thank you.
Bye.
Bye-bye.
Bye.